React compiler. Today we are going to make this exciting deep dive into this new tool. But first, when you start with a React application, you start really clean code. Everything is well structured. You have some patterns in mind. Everything should be really clear in all your path. But after a few days, you start seeing weird things. You start having some project manager telling you that you have to be faster, and everything is just a disaster. And so maybe you start having problems at some point. Your application becomes slow. You have some performance problems. And a lot of times, render is the main issue because you know how React works. We have this render engine, and you have to keep in mind that some triggers are going to make your components to re-render, and a lot of time you have a lot of re-render. And a lot of these re-renders maybe are not necessary. For example, here we have an easy structure with a parent component with a lot of children. And maybe at some point, our parent component is going to make some re-render, state is changed, the props somehow is going to re-render. And all its children are going to re-render, and you have to keep in mind that you have to manage these kind of things, because maybe at some point you have a children you have some child that is going to be slow while you render it because he has to make some really heavy computational stuff. Maybe you have to filter an array, this kind of stuff. And without any reason, you are re-rendering it. But we are developers, we need to find solution. React gives us a lot of solution to do that, and we can use memoization. Memoization is a technique to cache our things in React because maybe we don't want to make something at every component render, but we would like to use a cached version of a value, of a function, or maybe of the whole component. So we have this kind of hooks. For example, here we have a component. It has a prop title, and it got a filter Pokemon function on, let me say, an array, but it doesn't matter, that is really slow. And we have a common scenario where the title changed, you have the re-render, and then you have your filter Pokemon executed again. And so what you can do, you already know because you are a React developer, that you can memoize your value. In this case, so you use useMemo, you use a dependency array, and you keep your filter Pokemon safe from the re-render caused by the title. Yeah, and what ends is that I saw that a lot of time you start using useMemo, useCallback everywhere, because it's easier to say, okay, it's better to catch something. I love Boris memos. I prefer to use one more useMemo than one less, but it is not always the best, of course, because a lot of use case show us that maybe it's slower caching than not caching. But anyway, we just use it a lot of time, and maybe some good developer use shortcuts to do that. But well, we are talking now about React 19, that it would be the next version, the major version. With a lot of great improvements. A lot of things are going to be in this new major release. A lot of things that Next.js loves to spoil to us. Next.js make a lot of spoiler about canary features. And so we already are familiar with server component, all these kind of things. But the next major version will have all this kind of stuff. And with this announcement, they also start talking about the React forget. No, this is the old name. Now we have the React compiler. So they are starting introducing us and let us work and try the React compiler. And a React compiler was really an hard name to hear, because what are we going to do? Are we going to compile React? And so the first things I thought, the first time I heard about the React compiler, was like, okay, we had in the past the class component, now we have function component. Are we going to have binary component? Are we going to have some, to deal with this kind of stuff? Of course, it was a joke, but it was like, I used to see at university about what a compiler does, and I cannot imagine how to use that with React. But at the end, we saw what's behind the forget and now the compiler. And this is how a compiled component looks like. You can see on the left a normal component, and this is the same component, but after the compiler make his work. But you can start saying, well, maybe we already have a compile, right? Some compiling when we have a React application, because you write your component, everything is clear, but at the end, you are not using that code on your browser. So you say, well, there is Bubble that is doing something as build, why I'm using Vite? And you are right, because we are making some compiling that maybe is most, we should use the word transpiling, because we don't want to have types on our client. We don't want to have JSX directly on our client. And we love to use modern JavaScript, but at the end, we want that our JavaScript can be executed on most of the clients. So there is a process already that transforms our code. But what the React compiler would like to do with our code is to also to improve our code, because we were talking about memoization, useMemo, useCallback, that is trying to improve our performance, but is going to decrease our developer experience, because we have to write all the useMemo, useCallback. So the React compiler would like to make that for us and automatically use caching on our component, and also to optimize our code and have like React under steroids. But first, we need to know that to use the compiler, we need to respect all the rules of React. How many of you knows the rules of React? And how many of you respect the rules? Yeah, it's a nice topic, because React provides us a lot of rules that allow us to have a better application, to have some directives that can help us to have an application without bugs. Of course, we are going to have bugs, but these are all rules that help us to have a better experience while developing, and they are mandatory if we would like to use the React compiler. Just to show you few of them, there are some really easy to understand rules, like you shouldn't call an hook at top. You should call hooks at top level. So you shouldn't, for example, use conditionally a hook, except use, but we don't have to complicate it now. And so this is easy. We should always have our hooks at top level. This is really a rule. You should do that. You shouldn't try what happens when you don't follow this rule. Another one is that props are immutable. So you shouldn't change a prop. A prop is a way to pass some value, something, or a function from one component to a child. And if you want to make some update on that, you should just create something new. So please don't play with props. Just use it. Another one is that components must be idempotent. What does it mean? This is familiar for in functional programming, where when you have the same input, you expect to have the same output. This is like what we should have. And here, we are not having the same render results, because we have a date is going to change. So if I render again this component, of course, my render results will be different. So of course, if we need something like date, for example, that of course is going to have some different rendering during time, you can use hooks, for example. Like in the example, you can use a use effect with a state, you creating your hooks. So you should wrap this kind of behavior inside an hook. And so you are following the rules, and maybe you are using React 19. You can also try the compiler with other version, but here we go with the React compiler. So we can use this new tool. Make a step backward. What is a compiler? Because especially if you are a front-end developer, maybe you are not familiar with compiling because you know, we always thought compiling is going to take our code high level, something that we can understand, like an English version of something, or like really an high level, like ChatGPT coding, to a low level, a binary code, for example. And you have different steps during compiling. So the compiler takes your code, try to find some token, to create like a tree that have some syntax logic that transform your code into another structure. It creates some intermediate code while doing that. At the end, it will like also to optimize your code and generate at the end the result. And the React compiler is going to make something similar. It's not going to create binary code. And the process is similar in some way, but of course it's different. We have something that is in common with what we saw before, like we create with Babel plugin the abstract syntax tree. You have some intermediate code. You got the optimization, because this is one of the goal of the compiler. At the end, you will get your new component. And you have different components that are in the compiler. There is a Babel plugin that is going to make some work. You have the linter that you can use also without the compiler, that helps you to understand, for example, if you are respecting the rules. And you have, of course, the core compiler. But let's see the code, and let's try to understand how the compiled code is structured. So this is the example. On the left, we have our function component. We already saw that. We have a prop. We have a function with a value. And then we have the result, the JSX part, where we have our prop and another component that is using the other value. And so here, as we saw in the example, if the title is going to change, the filter Pokemon function is going to be executed again. So we should use memoization, but the compiler is trying to help us and make that for us. So this is the code, and we try to explain. I hope that I can do that without making some confusion. Let's start with the first line of the component, new component. If you look at this component, it's similar. You have a function is with the same name. You have an argument that could be our prop, and then at the end you have a return. So it's similar, but it's just a little bit. It's also minified a little bit. There is some really short name for variables, but it's similar. So we start with this dollar, with this underscore C. That is just, you can see that like create an array of 3 elements, an array of state, because I want something that will persist in rendering. And yeah, at the beginning, the first time this component will render, we have an empty array of 3 elements. So dollar is easy, just an array. And then we have our T0 that you can see as props. And here we are just destructuring our props to take the title. And then we have the first part. Here we would like to translate the execution and the rendering output of our filter Pokemon function. So we have this variable, T1, it's just a variable. And then we check if we got something inside our array. At the first rendering, dollar is just an empty array. So if we take a look at this if statement, you see that we have that at position 0, we have this comparison, because we are trying to see if there is like a placeholder in the first position of the array. So we are saying, is it empty, our first position in the array, our position 0? And yes, it's empty, so we are going to execute filter Pokemon to get our value. And then we are storing the whole component that we are going to use with filtered Pokemon inside a variable. This is because we want to cache what the output will be. And then we take this cache, this value T1, and we bring it inside our dollar array because we want to cache it. So this is something like useMemo, but just to say we want to cache this value inside the array, the dollar array. Otherwise, else, if there is already a value in $0, just use it. So T1 will be the value that we calculated before. Then we move to the T2, to the other part of our component. That is just about the title. And we are checking if at position 1, so the second position of the array, the title has the same value. At the first render, dollar in position 1 is empty. So we enter in the if statement. And we bring everything we would like to render in this component inside T2. So this variable will have the whole output of our component. As you can see, we are using at line 17 the variable T1. So we are not going to call again our list to make something about that. We already made it before. We are using a new value or a cached value. So here we are creating the whole component. So T2 will be the output of the component. And then we will cache everything. We will cache the prop, and we are going to cache the whole output of our component in the last position of the array. Otherwise, else, we can use directly the cache. So this is like the mechanism. Check if everything is the same, and if it's the same and it's cached, use the cache. Otherwise, don't use the cache. And you have to have an array somewhere with this value. And you try to store everything you need. You try to store all the variables, all the props, and all the JSX, because also JSX is cached. At the end, we have this T2 variable that has our whole output, so we can return it. And this is the same of writing return div blah, blah, blah. And so now, I hope that all this code is clear, but this is how it looks, our component, after the compiler made his job. As you can see, he's trying to make some kind of caching for us. And so performance will be better because we are not using useMemo in our component, but at the end, we are like using that. And so this is the comparison. You can try yourself. You shouldn't trust in me. Is in beta version now, the compiler, as already Matteo's told. You can try, of course, installing in a new project. Of course, don't use it in production, but you can also try that to improve your code, but you will find some bugs, maybe especially in some library. You can also have to configure this kind of plugin because you have the linter that is going to be to add some rules to check on your code. And you can just use the linter if you want. I think you are all using linter in somewhere in your project. In this case, you have this React compiler linter that is going to change things and rules of React for you. If you are going to use using the Bubble plugin to have the compiler, you have to configure it. You can also use the playground. There is playground.react.dev when you can have just an immediate translation of your code. The first time I used that, I was like, what is doing this compiler? But now you are all familiar with that, so I'm happy about it. And you can also see the comparison code. So it's a nice way to see how a good React application, a good React code should be. I know that it's not maybe readable, but a little bit. And you can see that he's just trying to avoid to make recalculation, re-rendering, a lot this kind of stuff. Also, the React Dev tools are ready. When you use the compiler, you will see in your dev tool that the components are magically memoized, and this is cool. Of course, if you are going to have your React compiler, everything should be compiled, but you can also opt out something. Maybe you don't need to compile something. From the React documentation, this could be the case when something is not working, especially a library. And so maybe you can say, okay, here, don't look inside this component, just using useNoMemo, because they like to make this kind of things. So I imagine a future where we have a use client, useNoMemo, but with a use server inside somewhere. Maybe not best solution, but it is what it is. You can also have an opt-in way to work with the compiler. So you have an annotation mode. So the compiler is just going to compile if you use useMemo. So please use useMemo if you want to try it. And so, of course, it's great, of course, because it's going to give us a better developer experience, first of all. It's going to optimize our code, because it's also trying to remove some dead code. It's going to try to make inlining function. So it is trying to get our code in a better performance, and it's also going to force us to respect the rules of React. That is also really a good thing. But maybe you should always know how things works under the hood. You should know that you have a lot of renders that you don't need. You should know how your tree is built. You should know how React works. So we are going to have a lot of magic now. We are going to have a new layer, Yahoo, but that we could also have a lot of new problems that we cannot imagine. So you can try now. You can also experience a better performance, but please just try to understand how everything works behind you. So thanks. All right. Any question? I can. No.
Okay. I'm going to take a question from the audience because it's easier right now. What?
First of all, thank you. It was a very nice speech. As we all know, the current state of React, as you said before, we shouldn't use memoization for everything, right? So use memo, use callback. There is some cost in doing that, and so we should be considerate on whether we should use it or not. So, of course, I have no idea how this memoization process is going to be different from the useMemo and useCallback that we have now. So does that mean that because it's going to use by default on every calculation or function, that it's going to have, it could have a bad impact on performance?
Thank you. This is a good question. I made the same question to myself while preparing that. What I thought, this is all, the whole process is at build time. So I think the big difference is that while use callback and useMemo is going to be when at runtime, so while your application is running, you got all this code just at build time. So it should be better. I'm sure that this is the goal of the React compiler developers, but who knows?
Okay, so more questions. Is it mandatory to follow the React rules?
In general, it's not mandatory. You can do whatever you want. I saw a lot of people using hooks in an if statement, after an if statement, inside the return. You can do whatever you want, but you will have a lot of bugs. So you should. But React compiler, first thing is going to do is to check if you are respecting the rules with the slint plugin. So you have to, if you would like to use the compiler, but you can also be a crazy guy and just do whatever you want.
Okay, maybe you have to help me here. How the compiler know the length of the? How the compiler know the length of the dollar
okay,
sign?
the dollar array. Yeah.
The dollar array.
Yeah. This is something that the compiler make when he analyze your code. So it's not like a random number, but it's going to take a look at the props, the stuff you are rendering, state. You should try the playground now, because this is like the simple version, but it's almost what the compiler does. If you take something different, like a count state, for example, with different hooks, you will see a different output, and the compiler will take for you care of see what it has to be cached, and you will have the array size with that.
Okay, one more and then I. Can React compiler be used with React 18, or is it something apart from the, or is it something apart from the
Yeah,
React
yeah,
version?
you can also with 17, I think. Yeah, so you can use with older version. You should maybe use another tool to do that, from the React compiler stuff. But yeah, you can. So I think 17 and 18.
Yeah, quick question. Do you know if the compiler, the suggested approach is to also compile the third-party components, or by default React suggests, and the way it's implemented currently in Next doesn't suggest to compile also the third-party components?
Well, what I saw in the documentation about that is that if you have third-party components, they can be broken by the compiler. And this is where they talk about the opt-out version of the. No, if you have a component that is using some library component, and you have some errors, I think the easiest approach for me is, okay, I have an error after using the compiler in the whole application, because I'm using this library in this component. So there, I'm going to write useMemo, because it's going to call the library. I think it should be enough.
Okay. By using the compiler in a real-world large application, maybe by a migration from React 18, do you think the final bundle size will increase by a lot?
This is a good question. I think everything will be optimized by the compiler. We saw a little bit of minification in the compiling process, and of course there is the wall build CI that you will have in every application where the bundle will be managed. So I think you just have to test. We are just in beta, I don't know, three days now, so we have to play with it. So this is a good example of something we should try. I'm not sure.
Are there performance advantages compared to just memorizing everything manually?
One of the goals, there is a nice document in I think in the compiler repository, I don't remember, when they write the goals of the compiler, and one of the goals is just to forget about using hooks. So they would like you to just use hooks, but go with the compiler. I think it's too early to say that we are going just to use the compiler, but maybe I think that should be the direction. Just avoid making manual memoization, and if you need to memorize something, just use Memo, or just have the compiler in the project. I think that is the goal, but we are just in an early stage.
Can I forget useMemo, useCallback, and Memo using the compiler?
Yes, but you should know that they exist. You should know why they exist. You should know how the React process works, what is the rendering, why your state is rendering, why set state is going to render, but if you call shoot set state, they are not working, this kind of stuff. You should know how everything works, because a lot of bugs that you have is just because you don't know how the whole render process works. I have a lot of bugs, but if you are just sitting down and say, okay, what's going on here? I have a prop. Is the prop changing? Because the prop is going to trigger a render. So yeah, I think that maybe in the future we are not going to use this kind of hooks anymore, but you should know why we are using them.
We have not finished yet. Someone asked the same question for you and for Alexandra in the other room, but I guess it's a question for you.
Okay.
We have seen a fairly simple example, but in the case where multiple props are passed, how does the compiler create a unique key for the storage area? Maybe it's not for you.
Maybe I have to read it. How does the compiler create a unique key for the storage area?
Maybe it's not a
If you have multiple props, you will have different elements. I'll try to think while talking. You will have different. Yeah, you see T0. It was props. It was just one variable, and then he destructured that for you. So I think that you should just think that he's going to analyze your code first. So it's not like magic. Another thing I didn't mention, that compiled code is just someone else's code as everything. A compiler has been written by someone, and so someone is going to transform your code. So there is some logic behind. You can also see the logic somewhere, but it's really complex. And so your code has been analyzed. You have this token. You have this structural version of your code. And so there, after some analysis, that's why it's having this kind of analyze at build time. You don't have too much to think about performance because it's build time. So just really slow CI, but it's okay to have slow CI. And so maybe you just have to look at how the compiler is going to analyze the code, I think, after it creates the abstract syntax tree.
Maybe the last one. Oh no. Yeah.
Maybe you are just joking. You are writing the question.
Do you think React will replace useEffect with some watch method
Do you
like
think
view?
you replace useEffect with some watch method like view? Oh, don't you like useEffect? It's so nice to see useEffect. Well, I have no idea the direction of React. I have no idea what will be the future. Maybe we will have signals. There are a lot of things behind the future of React, and I have really no idea if we are going to have something similar to watch. useEffect is used maybe too much because it's like a mental paradigm. Okay, I need something asynchronously, so let's go with useEffect. But we already have now server component that are doing something similar. So like the classical usage of call an API inside the useEffect is no more needed. And we have a lot of new libraries that are really good at helping us to have things that should be asynchronously. And so maybe we can have something similar, but I have no idea. They are getting harder.
They continue. So I don't know. Just choose your question. Ask yourself a question.
Myself, why are you here? Which one?
Yeah.
Okay, the first one. It's the shorter one. Does it already work with TypeScript? Does it? Yeah, of course. But you know, you have different stage, and remove types is the easiest stage in your transpilation process. And so, of course, but we shouldn't use JavaScript. This is another point, but you should just use TypeScript. If it's not working with TypeScript, just don't use the React compiler. That's my point.
Okay, let's choose last question because there are many coming up, but maybe you can then discuss
I will
during
be
the
around
break.
all the whole day.
Okay.
You can follow me on.
How safe it is to use the compiler in production for a mature and established product? For example, has it ever happened that while memoizing it skipped some dependencies, were missing causing stale data, or worse, like stale closures?
Okay, well, it's a beta tool, so you should be really, really careful using that in production. There was a nice article about a memory leak happening in React that is still happening also with the React compiler because the closures are going to have some value. So I think that is not ready at all. It's not going to solve all the problems of a React application. This is the goal, because you should just think about the logic of your application, and so the compiler is just a piece inside the process to help you just to be focused on the code and not on how React works and why React do stuff. But yeah, it's not going, especially in really some use case could just have the same bugs that you have without the compiler. I'm not sure it's going to break anything. Maybe it's going to break some libraries, but maybe your code could be safe. In the documentation, they say you should try to use the compiler, but I'm not sure. I'm not going to use it so often now, but I'm just playing with that and waiting to see what will happen.
Okay, as promised, was the last one.
Okay.
So we
Thank
can
you.
continue. So, a great round of applause for Giuseppe. Thank you.